To operate the autoclave, we need, of course, water. The water must be of good quality. If our water is hard, then it will harm the heating elements. So this is why we installed the water softener. To test the water softener, we first test our supply water. So for testing, we test the water hardness with a normal test stripe. Then we just put it under the water for 1 second. And we see the water quality, and also we can check the pH. Okay, again I take out one of the test strips. And we can test inside here. Water's not hard. Yes, just put it inside for 1 second and the water quality in the hospital is not bad. So we can see that actually.
But you know it comes from the potable water
Yes.
normally.
So we can see that already the supply water has a very low hardness. And after treatment, all the hardness is gone as it should be. And also the pH is quite fine in the range of 7. Oops, sorry, this way around.
Yeah, it's
Yes,
just neutral,
good.
around neutral.
Yes,
Yeah, it's fine.
yes. So not much changes. Everything is fine.
Yeah.
The supply water quality is already pretty good. So
Yeah.
better than in the other places we had.
Yes.
So this is for the testing of the autoclave. We start with the first test. The first test is the Bowie-Dick test. We use the Bowie-Dick test to check whether the autoclave is able to remove all the air. We have different type of Bowie-Dick test. This is the Bowie-Dick simulation test. So it simulates actually the conditions in the autoclave. For usage, we just take the simulator. We can open it. And the test stripe comes in here between. So we take out one test stripe.
Just one.
Just one, yes.
Yeah.
We fold it. And we just put it inside. And we close it tightly. The task of the autoclave is now to remove the air out of this simulator, which has this long pipe inside. So all the air has to go out of the pipe and has to be replaced with steam. And then the simulator is placed into our trolley. So we can go to our trolley and we just place it in the trolley at any place people want. The second test we want to do is the so-called helix test. The helix test consists out of one long pipe and with a place where we can put our indicator, here, like with the Bowie-Dick. The task of the autoclave will be now to remove all the air out of the long pipe, replace it with steam, and then to penetrate our indicator for a certain time and at a certain temperature. So again, we take out one of our indicator stripes. This one is then especially for the helix. And again, we place it inside. We close it tightly. And then we can connect it again, or we can put it again in our loading carriage. Thank you. And I just put it into the trolley. Then we also have our standard chemical indicator, type 5. These are our standard chemical indicators. The chemical indicator will only change color after a certain time and when a certain temperature is reached. So you can see here when the color will change.
Okay.
So for example, at 135 degrees, after 3 minutes, the color will change. So we can take some of these indicators, and the chemical indicators we can place at different places in the trolley. So to see if the right temperature is reached at all places.
All places
Even-
in the trolley.
Yes, even under difficult situations. Or we put one in the bottom, or we put one in the middle, wherever we want, we can place them. What we also want to do is we want to check if our autoclave is able to kill all the bacteria. Therefore, we take biological indicators.
Yeah.
The biological indicators contain spores of the most difficult to be treated bacteria, Bacteria thermophilus. And this bacteria, the spores, will be killed at a temperature of 134 degrees. So these are our biological indicators. We normally take,
2 or 3.
oh, sorry to say, even more. We have to take,
Okay.
yes,
To be sure that.
5 of them,
Okay.
Plus
Put in the trolley.
one blind probe. And then we put them at different locations at the
Yeah, yeah.
trolley. We maybe can glue one to the top.
One to the bottom.
We can put one on the bottom. We can put one somewhere here. For the testing, we want to put our machine in real life conditions, and we want to simulate the testing of a waste load. So what we want to know is not what is the temperature and condition in our treatment chamber or in the trolley. We want to know how is the condition in the waste. And to simulate the waste, we use a so-called linen pack. So what we do is we take linens and we put our biological indicators into the linen.
Okay.
So it's a difficult situation. So just put one inside, yes, perfect. And then we also can put one chemical indicator
2. Okay.
in the middle. And then we can wrap the whole pack. If you want, you can put the second one inside.
You can feel
No problem.
with the test, with the chemical.
Yes. And then we can wrap it with the autoclave tape. Thank you. Yes. So that it will be really difficult for the autoclave to reach the temperature.
To reach the temperature
Yes.
inside.
Inside, yes.
It's sufficient or we need to...
It's fine. Anyway, later on we will put also the probes for temperature testing inside. So that this also can be put in our trolley. For the commissioning testing, we will also do the temperature measurement. For the temperature measurement, we put our probes into the autoclave and we connect it with our data logger. And by this, we are able to see how the temperature is at different locations inside our trolley and also into our linen pack. So the data logger will record the data, the temperature, every 5 seconds, so that we know how is our autoclave doing during the process cycle.
So after we can load to the computer also.
Yes, yes, we connect this to our computer, we can get the data, and then we can see the treatment cycle, how it was in reality. Okay, this means that we can load our trolley. As said here, our probes, the probes are hot. Get them out, and we can put them into the trolley. From the 4 probes, we keep 1 outside, 3 inside. 3 inside, yes. So this one will show us the temperature in the chamber, and this one will then show us the temperature in the trolley and also in our test pack. Slowly, slowly, slowly. So again, we have our linen test pack, and we take 1 probe and we put the probe in the middle of our test pack at the most difficult place. And then we can take 1 probe. You have some autoclave tape? Some tape. And this one will show us the temperature at the lower part of the autoclave. And the second one then will show us the temperature on the upper part of the autoclave. Okay, so what do we have now? We have our biological indicators in our autoclave.
Chemical.
We have our chemical indicators in our autoclave, plus we have the challenge testing in our autoclave in the trolley. So we can close it, and then we can push our trolley inside. Slowly, that the probes are not falling out. Okay. Of course, we also will keep the record of the cycle. And we can put 1 chemical indicator. Okay. And then we start to record the data. So we press it for 3 seconds, and then it starts to record now the data.
All of the data.
Yes. And we can see already now the different temperature at different places in our autoclave. Okay. Now we will have to wait for the treatment cycle until this is finished, and then we can check conditions.
All of the tests.
Yes, yes, yes. It will take 1 hour. The treatment cycle is finished now. The first thing what we do is, we check the printout. The printout says that everything is okay. We have a total cycle time from 53 minutes. Everything seems fine. But first let us do the 121 degrees cycle. The temperature.
Yeah, pressure.
Yes. So feel free to put them wherever you want. We want to test the temperature.
Yeah.
We want to be sure that the temperature is reached in all places in the autoclave. And not in the chamber, but actually inside here.
So 121. What do you think?
We put later more inside. So you put indicator inside?
Yes, one, just one.
A foot. Sao hả? Chụp biết cả.
Please.
Yeah,
Put them at the most difficult places and don't forget to put one into the linen pack. Most important thing is you must be 100% sure that the autoclave is working. Because can we see bacteria?
No, we can't.
We cannot see virus, so we cannot see if we killed them. So we must test it by this. Going for thermometry testing again. We keep one outside. Press it longer. Longer, still on weight. Just press it 5 seconds, yes, continuously.
I don't know if we record all of the data.
And he will record now every 5 seconds. We can check our chemical indicator, which was outside of the trolley. It changed color to black. Looks good. And we can collect our biological indicator. We'll see later what we do with it. Then we can take our trolley out. Okay, and then we can start to collect our indicators.
All of chemical and organic external.
We have to be careful, it's hot. So we see we did our chemical indicator testing.
Measurement, yeah, that's a measurement. So we pass through.
They all pass.
Black, but
Then we take our Bowie-Dick simulation test. Again, careful, it's still hot. We open it and we check the color. And we see we have a complete color change. So again, this means that our autoclave is able to remove all the air out of the autoclave. Thank you. And also here we see complete color change. So we have our test pack.
bio. We need to put in the incubator, no?
Yes.
The second one. And the second one.
Be careful, hot. Also change color.
There is.
You will find it. I said, these are our biological indicators. These indicators were now autoclaved. In our biological indicator, there's a small stripe with spores on it. The spores so far are not in connection with this liquid. So what we have to do now is we have to break
and
to shake.
to shake.
So to make it quite easily, we can just put it into the incubator. We break it,
Yeah.
we shake,
After.
and we put it inside. Alright, we first have to break it, and then shake it, and then we can put it inside. Okay, and then we take one blind probe, one which was not in the autoclave, and we do the same. We break it, and that's it. Okay, if we mix up, how do we know which one was in the autoclave and which one was not in the autoclave? There's a little trick.
Yeah.
Look, there's a test stripe on it, and he did not change color. So this was the one which was outside,
Okay, yeah, I see.
and the other have color change. Oops. We bring the incubator to our office, we switch it on, and it will automatically go to a temperature of 57 degrees. We incubate for 24 hours, and then after 24 hours, we should see a color change.
Okay.
But we should only see a color change with the biological indicator which was not in the autoclave. The ones which were in the autoclave will not change color because the spores are hopefully dead. The one outside will change color because the spores are still alive. Become bacteria, and then the vial will change. When we see a color change of the ones which were in the autoclave, then we have a problem with the autoclave and we need to maintain our autoclave.
Ile testa voidique manga izy tamin'ny voalohany tamin'ny mbola tsy nitsofoka tato anaty autoclave. Rehefa après an'le cycle dia miviry mavokely le mavokely moa ty sa volomparasy mavokely le lokony. Izy ty tsisy tamin'ny voalohany fa rehefa miviry misy an'ity le an'ity manga ty dia ohatrany hoe ok zany le test. Rehefa ka ray fotsiny
We did the thermometric testing during the Bowie-Dick test. What we did is we put 4 probes at different places in our trolley. One of the probes we put in a linen pack like this one. This mainly to simulate the Bowie-Dick test so that we understand what happens in our Bowie-Dick test. So the Bowie-Dick test is a standard test like this one. The autoclave must be able to remove all the air out of the pack and then during 3.5 minutes to heat up the test pack to 134 degrees. And just to control our Bowie-Dick test, we put the same also in the linen. And we can see here nicely the influence of the linen on the temperature development in the autoclave. So during the first and second time of vacuum, where we could not remove all the air, we also can see that hardly any increase of temperature is visible. But then after the third vacuum and after the fourth vacuum, when all the air was removed, the cold island problem was solved and the temperature increased. So we can see that, yes, the autoclave passed the Bowie-Dick test. We also see it on the color change in our Bowie-Dick, and also when we used the simulator, we saw that, yes, it successfully passed the Bowie-Dick test.